All right, today we're going to be looking at question 2014 from the AB exam. This is a type 3 interpreting graphs question, and we have a function defined by an integral. So right off the bat, it's always safe to write g prime of x equals the derivative of the right side. The fundamental theorem of calculus tells us is f of x. Consequently, we could also write g prime prime of x is f prime of x. Okay, that information is quite useful in saving you if you forget to write it later on. So find g of 3. So g of 3 is asking us what is the integral from -3 to 3 of the curve provided, f of t. So when we look at this graph, -3 right here, up to this point, we have a triangle. So we are going to accumulate area. So our positive accumulation is that first triangle, which has a base of 5 units and a height of 4 units. So 1/2 of 5 by 4. And then we are going to be losing this triangle of space. So we're going to lose, oops, not equals. Lose a triangle that has a base of 1 unit and a height of 2 units. Okay. That's going to be 20 over 2 is 10 minus 1 for a total of 9 units. That is part A, and part A is worth 1 point. 1 point for your answer. Keep in mind you need to have work, so show the work that leads to your answer. Actually, this is probably the best way to express the work that leads to the answer. But there we go, part A. Let's move on to part B. Part B is asking us on what intervals is g increasing and concave down. So g of x is increasing when g prime of x is positive. Remember, g prime of x is the same thing as f of x. And g of x is concave down when g prime prime of x, is negative. Another way of saying f prime of x is negative would be saying f prime of x is, sorry, not f prime, f of x is decreasing. So we're going to be looking for a spot where f of x is positive and decreasing. So f of x is positive and decreasing on the intervals -5 to -3, positive and decreasing, as well as 0 to 2. This is worth 2 points. Your first point comes for the answer, and your second point comes from the reason. So let's go ahead and put this in parentheses, i.e. Moving on to part C. Part C appears to be introducing another function, h of x, and they want us to find h prime of 3. So this is just assessing some derivative rules. And what we have here is a quotient. So if we want to evaluate a derivative of a quotient, we should use the quotient rule. So the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. So there's our general derivative doing symbolic differentiation on this equation. And now we want to evaluate it at 3. So h prime of 3 is g prime of 3 times 15 minus 5 times g of 3 all over 15 squared. And we're going to need to evaluate g prime of 3 and g of 3 off of the table, sorry, not the table, the graph. So g of 3 we've already evaluated from part A, but g prime of 3 we need to pull. Since g prime is the same thing as f, g prime of 3 will be the same thing as f of 3. So f of 3 is negative 2. So we get negative 2 times 15 minus 5 times g of 3. G of 3 we established in part A was 9. And then 15 squared. Now this is a numeric answer, and this is sufficient for credit. But should you go down the possibly dangerous path of simplifying, you would see that this simplifies to negative 75 over 225, which further simplifies down to negative 1/3. This is worth 3 points. The first 2 points comes from correctly finding h prime prime of x. So using the quotient rule and getting that symbolic differentiation done is 2 points. Your third point comes from finding the correct numeric answer. And I again recommend it's safe to not simplify once you get to something that's numeric. So I recommend stopping there. Okay, let's move on to part D. All right, in part D, we're introducing the function p. So we're pulling another function, and it asks to find the slope of the line tangent to the graph of p at the point x equals negative 1. So again, they're asking us to take the derivative and evaluate it at a point. Find the slope of the line tangent to the graph at x equals negative 1. So we have to find p prime of x. So let's start off there. P prime of x is the derivative of the outside times the derivative of the inside. There's our symbolic differentiation using the chain rule, the derivative of the outside times the derivative of the inside. P prime of negative 1, now all we need to do is substitute negative 1 in for x's. So f prime of negative 1 squared minus negative 1 would be 1 plus 1 times negative 3. P prime of negative 1 is f prime of 2 times negative 3. So f prime of 2 we're going to need to pull off of the graph. So the graph up here, f prime of 2 is asking us what is the slope when x equals 2. So we're looking for the slope of the graph here. And it looks like we drop down 9 units. 1, 2, 3, 4 units by 2 units. Down 4, right 2. So that's a slope of negative 2. Negative 2 times negative 3 is a value of 6. Okay, and this is worth 3 points. Again, the symbolic part of finding the derivative of p is worth 2 points, and then the third point comes from finding the correct numeric answer. All right, smash that like button. Have a good day. Bye-bye.